In this video I'm going to talk about the clutch pack because I've had this thing cut open. So I'll have a look at what's inside, and to be honest, from my initial look at it, this looks like it would be relatively simple to rebuild. Just getting hold of the clutch components. There are some aftermarket components available, and then I would go to a reputable torque converter rebuild place, because cutting this open and then welding this back again is stuff that they do all the time. So I think they would be the perfect people to do a job like this. Again, that's just my speculation from what I have seen, because clearly there's not much information about this. When the clutch is initially removed from the car, this is going to be sitting over the top. This is the cover that just spins on the bearing underneath. That bearing there is pressed onto that shaft. I'll put the designation of that bearing up because it's easily obtainable. Well, I just did an internet search on the spec of that and it just comes up straight away. It's a bearing made by NTN, but that's pressed on there. It's also pressed on the inside of the cover. And then there's the oil seal on the front here, which runs on the in that position there. And it looks like the way this is put together is they would initially press it onto here without that seal being in place. So they press it onto there. They then put that over the top there. Then you have access to the inner race of the bearing, so you can press it onto there, and then the bearing's put on. To get this apart, it pulls out of the cover, the bearing, relatively simply. So you just get something underneath here and just go around and just lever that off, and the bearing will be left on there. And then it takes a fair bit of effort to get underneath here because of the shape of this. Unless you get some special tools to lever this off, that was actually quite a bit of effort. And you don't need to remove that to open this thing up. So unless you wanted to replace the bearing, I'd probably just be leaving it in place and making sure it's perfectly clean before you put everything back together again. That seal there is also available from Porsche, and I suspect that that's a fairly common seal as well. But to get this apart, I'd seen videos online before where they cut this open in here, which is what I got the guy to start doing. And because this had been in a crash, this was actually a little bit bent, so he stopped. And as it turns out, if you just, there's a weld here and a weld here. So obviously the input shaft is welded to this cover on the front here. I would just be leaving that as one piece. Then that thin weld that's around here, you just cut through that. You don't have to go through very far, only a couple of millimeters, and that thing just pops off. So that's the inside there, and obviously the input shafts would be coming into here. If you were thinking of getting your clutch pack cut open to rebuild it, there's some of the considerations I would be thinking of. This is what it looks like on the inside with that top cover removed, and if you notice here, there's this ledge. That seems to be what that top cover sits on, and then the weld goes in here. So on the underside of that top cover that came off, and see that bit there is where that would be sitting down on here. There's a little bit of an edge here which is left over from the weld after cutting off, so I would be removing that. So this is all just a nice flat piece, and then it seems as though this just sits straight over the top like that and then just welded into place. And because you've got that ledge here, that's the thing that seems to set the depth correctly, so you have the correct depth in here for the clutch pack. If you were cutting it, that distance there from the edge, because it's sort of a bit of a raised, beveled edge at the edge of the clutch pack, but about 1.5 millimeters on the way in there, because it's a bit difficult to see, but this is sort of beveled off to the side here. But that edge there, which is the one that's furthest up in this direction, I would start the cut about 1.5 millimeters from that edge, and then working my way in so I didn't impinge on this or cut into the bit of the front plate, which is going to rest on that later on when you weld it back together. With the cover off, we can start to pull the inner parts which are connected to the input shaft of the transmission. So that's for the outer clutch there, which runs on the inside of the outer of the two clutches. And they've got the center one here, which just goes to the inner of the two clutches. Now each of those has a bearing in between, so it's just a needle roller bearing in a cage, and they are identical to each other. So they interchangeable. Normally these, when you're rebuilding transmissions, you don't have to replace these. I suspect this is a fairly standard bearing that if you needed to replace, you could, but normally you wouldn't bother replacing those if they're in good condition. And then we have the two clutches themselves. What is interesting about this, and it's a bit unusual, is the outer of the two clutches doesn't have a snap ring. I'm not sure if you noticed, and if you've ever pulled one of these things apart before, there's a snap ring here, which is a thing that the last of these steels presses against when the clutch is activated. This one, as you can see, doesn't have that. And what it does is once all this is welded into place, that last that pressure plate there presses onto that bit there, which is unusual. And when that is fitted, the top of that rim there is perfectly flush with that. So the way this would need to be put back together is once you've replaced all the bits inside, that gets plonked on the top, and the torque converter guy, whoever's doing the machining and welding, they'll have a piece of kit that holds this perfectly centralized, this is perfectly centered, etc. And then they have a machine that just seam welds that round there. So I would expect that would be exactly the same thing. Removing the outer of the two clutches pretty simply, you just turn that over and that just pops out. And this is from a 7DT45 transmission. So it's different to the 7DT70, and having had a look at the specs on the different clutches, etc. that are available, because there are some aftermarket replacements available for the 7DT70, is that the 7DT45, which is what this gun came from, has 5 friction discs. If you look at replacement packs for the 7DT70, it has 6. And it has steels which are thinner. So the steels on this one are about 2¼ millimeters thick. The steels on a 7DT70 replacement clutch components are 1.8 millimeters. So I suspect what they've done is that it's exactly the same outer assembly. They've just put an extra clutch pack in there, and it's a bit hard to know exactly what they've done with the 7DT70 without having it here in front of me. But what it seems to be is that the clutch friction discs are all identical, so it's about 2.6 millimeters thick. The steels are thinner, there's an extra steel in there, and they put an extra friction disc in there. Because what's interesting, normally you would have a thicker plate at the end where that snap ring sits on, or sits over the top of, which is your pressure plate, and it's thicker so it doesn't bend and that sort of stuff. What they've done is they've used 2 standard steels and they've just plonked those together. So I suspect what's happened, and when you do all the numbers of how thick things are, for the 7DT70 it looks like they've just kept that one there. They've replaced all of these with thinner ones, so they're 1.8 millimeters, this one's 2.25, and they've put an extra friction disc in there. That's what it seems like to me. Normally what happens is the friction discs that start to wear the most, the steels generally don't. So it would be pretty simple to go and replace the friction disc from this. The friction discs that I've seen replaced for the 7DT70 seem to be exactly the same dimensions as on this one. So if you wanted to rebuild this, and normally you don't have to replace the steels because they normally don't have any wear on them, you would just get the frictions from the one that you can get aftermarket, and then just replace those in here and put it all back together again. I reckon that'd be pretty easy. To remove the inner clutch, we need to remove the snap ring, and it just has this funny washer at the top. We have to compress these to allow those to come out. And then once it comes out, that little funny thing with those clips just comes out. Once we remove this thing at the top here, you've got a shim underneath it. Normally what I've seen in the past is that they use different size snap rings to make everything exactly the right height. Whereas with this snap ring seems to be slotted in there with no slack at all in it. So you can't put a thicker or smaller one in there. So there seems to be this shim underneath there. And then we have the pressure plate, and the pressure plate is quite thick, as you would expect. And then underneath that are all of the friction discs themselves. And there is the same number as for the larger clutch pack. I expected there to be more because it's smaller. That's kind of normally the case, but in this case there is the same number. So in this case here there are 5 friction discs. The aftermarket 7DT70 clutch replacements that I've seen have 6. So I'm imagining that the 7DT70, really the only difference is the fact that they have 6 clutch units, right, the 5 that's on these. The thicknesses of the steels and the friction disc in this are identical to the large clutch. So it's about 2.6 and that one's about 2.25, and the replacements that I've seen online is identical for the friction discs, and the steels are 1.8. The way this seems to be constructed, as you would expect, there are 2 pistons here that are going to lift when pressure is applied underneath. Normally you would be able to disassemble this using a compression tool to compress the big spring that sort of lives down in here. But the way this seems to be constructed is that it's all put together, pressed down, and then welded in place. So unless you cut that open, I don't think you get access to the pistons underneath. The nice thing about that though is that the way the pistons work is they're a big sort of donutty thing. It's kind of going to be kind of like that. That's going to move up and down. Obviously it doesn't have the ridges around the outside, and it has a big O-ring there and a big O-ring there. And in replacement kits they will replace those O-rings, but most of the time, unless a whole bunch of debris has gone through the transmission and really trashed the rubber in those, normally that's not really required from what I've seen. And so if I were just rebuilding a clutch pack because they've been worked on the track and I just needed to replace the clutches themselves, then I will probably just leave all this alone, replace the clutches, and then put it all back together again and weld it, and I reckon it should be good to go. There's one other bearing that would live inside here. They got completely trashed when this thing had a crash and everything just got bent out of shape, and from the bits, all I ended up with these bits here and the needles out of it like that. And from the size of the shaft that goes into it, so the smaller of the input shafts has a little knob that goes into that needle bearing, which would live in there. It has an 18mm inside diameter. These rollers are 2mm diameter, so that there is 22mm. And that thing there is about 10mm wide. So that's a bog standard needle roller bearing that you can buy from SKF or someone like that. If you do a search for it for a 18 by 22 by 10mm, and that would just be what goes in there. On the other side here, because this is where the pressure for the clutch fluid goes into, there are 4 of these hard seals, and these are pretty typical of what you see inside gearboxes. I'm not sure what they're made of. They kind of look like they're made of anodized aluminium, but they sort of slot in together, and so you sort of expand them out and put them in kind of like a piston ring. That's the sort of thing that would normally come in a rebuild kit, but I'd be inspecting those. And again, unless a whole bunch of debris has gone through here, then I probably wouldn't expect that you need to replace those. But I'll put the size of that up on the screen in a moment, just so you can have a look at those. I expect that these would be a common size because these are things that are used in transmissions all the time. So you might be able to find something that is identical to that if you need to replace them. And on the clutch input side here, obviously you can see the inputs for the 2 oils. The outer one here is for the outer clutch, and there, the inner clutch, I'll just show you how they move in a moment. I'll apply some compressed air to them. There's a hole here which allows, if we get, just say for example, a piston pressure is being applied to this clutch here, and you get a leak in this seal here, instead of it then going across this seal here, there's a little hole here which allows the excess to flow back into the inside, which is kind of nice. Lubrication flow comes in, there's a big bearing which is part of the intermediate plate and needle roller bearing that sits and runs on that race there. The lubrication flow goes in through these holes, and these bearings, they look like ball bearings, but they're not. They're just plugs for where the holes are, just the machine holes for where the clutch fluid actually goes. This is the outer of the two clutches. And the inner. To assemble, I would suggest just having all of your pack sorted before you even start in the order that it's going to go in. Clearly you need to put in steel, then friction, and then alternate those. I've heard of people doing those incorrectly before and spoiling their day, so make sure you do that. Pressure plate on. You've got a shim in there, so obviously going to go on. And that one, and this thing can just go straight on. Make sure it's slotted in there correctly around that, and then we can put the other one on. If it's like this and you've got the two discs which are acting as a pressure plate, they're going to go on last. Now once it's like that, we need to get our inner splines in. Normally with something like this, you'd have something to grab hold of to sort of turn those as you sort of wiggle and put that down, whereas these are a bit of a pain. That might go in there. Sometimes I find I need to get in here and align these. And you'll know this is in correctly and not sitting on the last of the friction disc. When it goes down, it gives quite a hard thump. If it's got a bit of a springy feel, it means all of those friction discs haven't been aligned correctly. It can sometimes take a bit of perseverance to get those in correctly. Then make sure the bearing goes on, and then this one can go in. And again, once this one's in, it's quite hard. The sound when it gets to the bottom, you know it's fully seated home, and you don't have that springiness. Make sure that bearing goes on, and then that's going to go on, get welded on, and you should be good to go. With this thing fitted on, this is pretty much flush. There's a little bit of a gap under there, but it gives you a bit of an indication of the clearance for the clutch pack inside. So if I put that, you can see that ledge there is where the clutch is going to compress to. So as you can see, that's about 12 millimeters, and the depth from that edge down is about 14 millimeters. So there's about a 2 millimeter gap between that and the pressure plate on the clutch for compression. That kind of makes sense. And also you can see, and this is pretty typical, the witness marks of the scraping of the clutch when it gets compressed in there. They'll be about 2 millimeters wide, which kind of makes sense. And that's pretty similar to the little scrape marks on the center clutch as well.